Today we're going to be learning about L'Hopital's rule, which is used to find the limit of a function in an indeterminate form. So let's start off with the definition. If the limit as x approaches c of f of x equals 0, and the limit as x approaches c of g of x is equal to 0, and the limit as x approaches c of f prime of x over g prime of x is equal to a certain limit, then the limit as x approaches c of f of x over g of x is equal to that same limit. And this is also relevant if f of x and g of x are going to plus or minus infinity. So this goes back to what I said about the indeterminate form, because if f of x is equal to 0, that means the numerator is equal to 0, and if g of x is equal to 0, that makes the denominator 0, in which case that'd be the indeterminate form of 0 over 0, and we'd have to use the derivatives of f of x and g of x to find the limit. And a common mistake here is when you're finding the derivative, do not use the quotient rule to find f of x over g of x. This is the derivative of f of x over the derivative of g of x, so make sure not to do that. So let's start with indeterminate quotient. So that is when we get a 0 over 0 or a positive or negative infinity over positive or negative infinity. Let's start with the first example. So the limit as x approaches 0 of sine of x over x, we're going to use L'Hopital's rule, and we're going to take the derivative of sine of x, which is cosine of x, over the derivative of x, which is just 1, keeping our limit notation. And we're going to plug in 0 for x, which will give us 1 over 1, because cosine of 0 is 1, and leave us with an answer of 1. And that's it for the first example. Moving on to example 2, the limit as x approaches infinity of e to the x over x squared. So this will go to infinity over infinity, so we have to use L'Hopital's. And the derivative of the top is e to the x, derivative of bottom 2x. This is still infinity over infinity, so we use L'Hopital's rule again, and you can use this as many times as necessary to come to a final determinant answer. So again, we get e to the x, this time over 2, and if we plug in infinity for x, we get infinity over 2, which is just infinity. That's the answer. So example 3, here this will go to 0 over 0, so we use L'Hopital's rule, and that's going to give us 20x to the third minus 8x over negative 1 minus 27x squared. And if we plug in 1 for x, we get 20 minus 8 over negative 1 minus 27, which simplifies to 12 over negative 28, which simplifies to negative 3 over 7. And one more example. The limit as x approaches negative 6 of sine of pi times x over x squared minus 36. We'll go to 0 over 0, so we use L'Hopital's, and we use the derivatives of sine of pi over x and the derivative of x squared minus 36. And we plug in negative 6 for x, and that leaves us with pi over negative 12, which will be our answer. Now indeterminate products. So for this, we utilize the idea that we can manipulate what we are given into something we can work with. So here we know that dividing by 1 over something is the same thing as multiplying by that same number. So we're going to use that to our advantage, and I'll show this with our example. So here, we're going to leave ln of x on the top and move x to the denominator and make it 1 over x. And for the purpose of finding derivatives, I'm going to change this to x to the negative 1. So now we can use L'Hopital's. So it's 1 over x to the negative 2. And I'm going to simplify that again into a fraction over another fraction, which means we can multiply these two and simplify into the limit as x approaches 0 from the right side of negative x, where we plug in 0 for x and get an answer of 0. And feel free to pause if you feel like you understand the concept and try these out before me. So now I'm going to change this to ln of x over 1 over square root of x, and change that again for the purpose of finding derivatives to this. Now we can use L'Hopital's. So the limit as x approaches 0 from the right, 1 over x over negative 1/2 x to the negative 3 over 2. Since this is a fraction in the denominator, I'm just going to move this out in front of the limit So it'll be -2. And the limit as x approaches 0 from the right of 1 over x over 1 over x to 3 over 2, since this is a negative. And like we did before, we can just multiply these two fractions, since it's a fraction over a fraction. And that gives us the limit. So x goes to 0 from the right side of 2 times square root of x. Substitute in 0. We get -2 times 0, which gives us an answer of 0. And one more. Here I'm going to change this to sine of 6x over tangent of 2x, since 1 over cotangent is equal to tangent. And apply L'Hopital's rule. This gives us cosecant of 6x times 6. Simple chain rule with trig. And if we plug in 0 for x, that gives us 1 times 6 over 1 times 2. 6 over 2 is equal to 3. And moving on from products, we're going to move on to indeterminate powers. So here we have an f of x raised to g of x. So in order to solve this, we're going to find the natural log of both of these. And since it is raised to a g of x and we're using natural log, we can just move this to the front. So that's what I did here. And this will become clearer with an example. So here, I'm going to make this whole thing y. So y is equal to e to the x plus x to the 1 over x. Now we're going to find the ln of y, which is 1 over x ln e to the x plus x, since I moved this to the front. Now we're going to find the limit of this. So limit as x goes to infinity for ln of y, which is equal to ln e to the x plus x over x. And this is indeterminate as infinity over infinity, meaning we can use L'Hopital's rule. So the limit as x goes to infinity of 1 over e to the x plus x times e to the x plus 1, so derivatives, and then x just goes to 1. And simplifying this, you can just get e to the x plus 1 over e to the x plus x, which is still infinity over infinity. So we plug in L'Hopital's rule again. This gives us e to the x over e to the x plus 1, which is still infinity over infinity. So L'Hopital's rule again. E to the x over e to the x is just 1, and the limit of 1 is just going to be 1. Now, common mistake is to think that that is just the answer, but if you think about it, we found the limit of the natural log of y when we were supposed to find the limit of y. So to fix this, we change it to this. The limit as x goes to infinity of e to the ln y, since these two will cross out and leave us with just y. And we know that ln of y is equal to 1, so our answer is e to the 1. Let's do one more example with powers. So limit as x goes to 0 of cosine 3x to the 5 over x. So this is all 1. Natural log of y is equal to 5 over x ln cosine of 3x. Now we find the limit as x goes to 0. 5 over x ln cosine 3x, which is equal to the limit as x goes to 0 of 5 ln cosine 3x over x. So now we apply L'Hopital's and find the derivatives with chain rule. And this can be simplified to the limit as x goes to 0, -15 tan 3x, which if we plug in 0 for x will just give us -15 times 0, which is equal to 0. But since we found the limit of ln of y, not y, we take whatever we got and make that the exponent of e, and that will give us our answer. Now, final thing, indeterminate differences. So here, all we have to do to solve this is factor out an x, and from here, just make this product. So we already know how to work with those. So we're going to change this to e 1 over x minus 1 over 1 over x. So keep this numerator, make this the denominator. And from here, just use L'Hopital's rule to solve. Thanks for watching.